just interact for every this thing so that we'll come to know that. In the triangle ABD and ACD, angle B and angle C are what?
90, sir.
90. In these two triangle, AD is same, right?
Yes, sir.
So in this two triangle, AD is same. Angle B and C are equal to 90 degree. Then when the ray travels from A to C, by the same time the ray will travel from B to D.
Yes, sir.
So you can say AC is equal to BD. AC is equal to what?
BD.
BD. So in any two triangles, if two sides and one angle are equal, from the concept of SAS postulate, if two sides and one angle are equal, so from the concept of SAS postulate, these two triangles are similar.
Yes, sir.
So if any two triangles are similar or congruent, their corresponding angles must be same. So what are these corresponding angles? I and R. So I must be equal to what?
R.
So that is the laws of reflection. Similarly, you can go with the Slen's law concept. How to prove the Slen's law? That is N1 sin I is equal to N2 sin R. Same concept, instead of reflection, the ray will undergo refraction, that is from A to C. In the previous diagram, we have taken AC in the reflection, right?
Yes, sir.
Now, here the refraction has to take place from A to C. The medium has changed. The speed has to change. V1 and V2 will be the speed. V1 and V2 will be the speed. Now, in this triangle ABD, can you tell me what is sin I? Opposite by hypotenuse, no. Is 0?
Yes, sir.
So what is opposite? V1T. What is the hypotenuse?
AD, sir.
AD. So similarly in the triangle ADC, what is sin R?
V2T.
Opposite is V2T by AD. So if I divide this equation 1 and 2, I'll get cancelled with T by AD and T by AD. So what is sin I by sin R then?
V1 by V2.
V1 by V2. And by the definition of refractive index, how V and N are related?
N is equal to C by.
So V and N are inversely proportional, no?
Yes, sir.
So V1 by V2 can be taken as what?
N2 by N1.
N1. So cross multiply. So if you cross multiply, you will get N1 sin I is equal to N2 sin R. So that is the concept of the Slen's law. Got it?
Yes, sir.
Okay. Now, the next concept, that is interference of light. Now, let me consider two light wave students. Okay. This is the first wave. I'll take the second wave like almost same concept, like this. Okay. If these two get superimposed, the resultant amplitude will be more, like this. Like this. Now, let me draw one more diagram for you. Jerome, this is one wave. Second one wave is moving in the opposite path. If I mix this, I'll get the wave like this. Correct, no, Jerome?
Yes, sir.
Now, what you have learned, this displacement amplitude, right?
Yes, sir.
Now, in the first diagram, both the amplitudes are in the same direction. But in the second diagram, both the amplitudes are in the opposite
Different.
direction. Yeah. If the same amplitudes in the same direction, if they get superimposed, resultant amplitude will be more. In the second case, the resultant amplitude will be less. Resultant amplitude will be less. So first case, resultant amplitude will be more. Second case, resultant amplitude will be less. Whenever this amplitude changes, there will be a change in the intensity because intensity is directly proportional to square of the amplitude. How the intensity and amplitude are related? Intensity is directly proportional to the square of the amplitude. So whenever the two light waves get superimposed, there is a change in the intensity of light, right? There is a change in the intensity of light. What is that called? Interference of light. What is that called?
Interference of light.
Yeah. So when two or more light waves will get superposed, there will be a change in the modification in the intensity of light. That modification in the intensity of light when two or more light waves get superimposed is called as what? Interference of light. In this interference of light, how many types I have written here? Two types. One is called constructive, the another one is called destructive interference. How many types of interference we have? Two types. One is called constructive interference, the second one is called,
Destructive interference.
yeah. In the constructive interference, what happens to the resultant amplitude and the intensity?
Increases, sir.
Yeah. If the resultant amplitude and intensity decreases, that is what we call what type of interference?
Destructive interference.
Destructive interference. So in the case of a constructive interference, the resultant amplitude and the intensity increases. In the destructive interference, the resultant amplitude and the intensity will decreases. And please remember, students, in the case of constructive interference, phase difference should be always like 0, 2 pi, 4 pi, 6 pi, like that. 0, 2 pi, 4 pi, like that. So the last number you can remember, it is 2n pi. So what is the condition for the phase difference for constructive interference? 2
2n
n
pi.
pi. Can you tell me path difference in terms of distance? For one complete wave, it starts from 0. For 2 pi, what is the distance? What is this called?
Wavelength.
Wavelength. Very good. So 2 pi is lambda. 4 pi is 2 lambda. Like that, the last number will be n lambda. So what is the condition for the phase and the path for constructive interference? For constructive interference, phase must be equal to 2n pi. Path must be equal to n lambda. Path must be equal to n lambda. Phase must be equal to 2n pi. So for destructive interference, similarly, the phase difference should be equal to 2n plus 1 into pi. Path difference should be equal to 2n plus 1 into lambda by 2. Please remember this. They may ask for 1 mark, students. What is the condition for the phase difference and the path difference? For the phase difference, For the constructive interference, what is the phase difference? 2n pi. Path difference? N lambda. For destructive interference, what is the phase difference? 2n plus 1 into pi. Path difference should be 2n plus 1 into lambda by 2. 2n plus 1 into lambda by 2. Please remember this condition. This is very, very important for 1 mark. Okay. And for 5 mark, they may ask to give the theory of interference. A very simple derivation, students, actually. Theory of interference. Can you tell me how many waves you required for interference, Jerome?
2 waves, sir.
Yeah, 2 waves. Let it be y1 and y2. First one, I will write it as a sine omega t. Second one, I will write it as a sine omega t, but extra angle, let it be phi is the extra phase. So if the first wave is traveling at 0 degree, the second wave is traveling at 30 degree extra. That extra phase I'm writing as phi. Then what is the resultant wave y? What is the principle of superposition? What is the resultant wave?
Y1 plus Y.
Yeah, just add up. What is y1? A sine omega t. What is y2? A sine omega t plus phi. What is the common you can take, Jerome?
A sin omega t, sir.
Only A, only A, only A. You keep this sine omega t as it is. What is sine of A plus B formula?
Uh,
Sine A.
Sin cos
Or
B.
do one thing. You write one thing. You write one more step. Sine omega t plus phi. Now use the formula, direct formula. You studied, no? Transformation formula sine C plus sine D. So what is sine C plus sine D? It is 2 into sine of C plus D by 2 into cos of C minus D by 2. So this is the transformation formula I studied. So what is sine C plus sine D? 2 into sine of C plus D by 2 into cos of C minus D by 2. Y equals to 2A sine omega t plus phi by 2, because omega t plus omega t will be 2 omega t. 2 omega t plus phi whole thing by 2. That is omega t plus phi by 2 into cos. This 2 will get cancelled. Cos of minus phi by 2. But you know that cos of minus theta is also equal to what? Cos theta, no? So this 2a cos phi by 2, I'll replace it as r into sine omega t plus phi by 2. This r is called as the resultant amplitude, that is 2a cos phi by 2. This r is called constant called the resultant amplitude. What is that r called? R is a constant called the resultant amplitude. This is very important. They will ask for 5 marks, students. And addition to this, please remember these conditions: phase difference and path difference. Any doubt in this?
No, sir.
Okay. The next concept is, actually the experimental concept was explained by the scientist called by the name Young's double slit experiment. So instead of explaining with theory concept. They have taken with Young's double slit experiment. Young's double slit experiment, YDSC. This is practical one. So here they are keeping one source. From the source, Jerome, can you see the screen sharing?
Yes, sir.
Okay. So from the source, we are taking the rays parallel. This is slit X. Here we are going to keep one more slit, that is Y. In this point A and this point B will act as the source. The separation between them is always denoted by D. Always remember what is D represents. Distance between the slits. So the interference pattern is taken on the screen. From the source to screen, I'll keep the distance as capital D. So what is capital D? Distance between slit and screen. Now you can take the interference here, center. At the center, always it forms a constructive one that is called a bright band. Then next there will be a dark. Next there will be a bright. Next there will be a dark, like that. So if I take at this particular point, it may be a bright band or a dark band, whatever it may be. Now please remember the distance of this is given by n times of lambda capital D by small d if it is a bright. So if there is a nth bright band, if this is the nth bright band, what is the distance of the nth bright band from the bright fringe? I mean from the central fringe? N lambda capital D by small d. This is for bright. If it is a dark band, here if it is a dark band, then it is n 2n plus 1 into lambda capital D by 2d. That is for the dark fringe. So what is the distance of the nth bright band? N lambda capital D by small d. What is the distance of the nth dark band? 2n plus 1 into lambda capital D by 2d. This is for dark. And also please remember the distance between the any two consecutive bright bands. If these two are the consecutive bright band, this distance is called the fringe width. What is that called? Fringe width. What's the formula for that fringe width beta? It is lambda capital D by small d. So the fringe width is given by the formula lambda capital D by small d. But this is not there. You can remember these two formulas for the problems. So this is how the Young's double slit experiment is analyzed by the scientist called by the name Young. But this question they won't ask students. But please remember, if they ask, what is the interference pattern consist of? What is the interference pattern consist of? What does this screen consist of? Alternative what? It consists of alternative bright and what? Dark bands, right? It consists of an alternative bright and dark bands. And please remember, all bands are equally spaced. All bands are equally spaced. So this is what we called as the interference. The next concept, students, that is diffraction. But here, if I consider the slit, whenever the ray of light travels like this, there will be a bending at the edges. There will be a bending at the edges. This bending is what we call as a diffraction. So what is basically a diffraction means? Bending of light. So bending of light around the corners of the obstacle is called as a diffraction. And please remember, Jerome, this condition, the slit width, must be comparable with the wavelength. The slit width must be comparable with what?
Wavelength.
Wavelength. That is the condition for diffraction. But in the 3 mark question, they won't ask the concept of the diffraction in this format. They will ask us to write the difference between interference and diffraction, students. Actually, there is one Fraunhofer diffraction concept, but it is deleted now. So remember the differences. What actually the interference mean? Modification in what? Intensity of light. But in the diffraction, it is what?
Bending of light.
Bending of light. Here, how many sources is required?
Two source.
But in the diffraction, only single source is required. And please remember, more bands are formed. But here, few bands are going to be formed. Few bands are going to be formed. And also you can remember, all bands are equally spaced. All bands are equally spaced. But in the diffractions, bands are not equally spaced. I mean, it is like this. If I say this is intensity, all bands will be in the same space. Okay. But in the diffraction, it is not like that. First band will be more, then it will decrease us like this. So the amplitude or intensity is not same here. Amplitude or intensity is not same. But in this case, the amplitude and intensity are same for all the bright bands. Please remember, this is very important for 3 mark. Actually, there is a Fraunhofer diffraction is there, but don't analyze in the exam. They won't ask. It is there in the book, but except that Fraunhofer diffraction, you analyze the differences, because they won't ask the diffraction, Fraunhofer diffraction experiment to explain for the exam. So I'm skipping that. But important for 3 mark is interference and diffraction definitions or differences. Addition to this, in the case of a polarization you have studied, what is the concept of polarization? You know, the light particles will vibrate in all directions, isn't it? Jerome, can you see the
Yes,
screen
sir.
sharing? Okay, okay. In which direction the light particles will vibrate? In all the direction the light particles will vibrate. It is going to vibrate in x-axis, y-axis, z-axis, in all possible directions. Now you bring the vibration in a single plane. The vibrations can be brought to a single plane. The method or the process or the phenomena where the vibrations brought to a single plane is what we called as the polarization. So what is polarization? Polarization means bringing the light particles to vibrate in a single plane. That is represented either by dot or by an arrow mark. This is called polarization. If there is both dot as well as arrow mark, then this is said to be an unpolarized. Actually, we can convert this unpolarized into a polarized by using a device called Polaroid. So what is Polaroid? What is Polaroid, students? device which converts what?
Unpolarized to polarized light.
Yeah, unpolarized light into polarized light. That is what we called as a polarites. You know basically where the polarites are used? It is used to view it is used in sunglasses, it is used to view 3D images, it is also used in automobiles to remove the glare. So if they ask to mention the two types, I mean any two uses of polarites, what will you write? What will you write? Polarites are used in where? Jerome?
Sunglasses.
Jerome?
So
Yeah,
sunglasses,
3D images and
images, and
automobile.
automobiles.
Yeah, there is one more very important concept, Jerome, that is Malus law. Malus law. See here, if I considered the two polarites, if I consider the two polarites, this is the first polarite, this is the second polarite. The angle between them is theta. If I incident a unpolarized light, if I incident a unpolarized light, after unpolarized, it will be get polarized, right?
Yes, sir.
Yeah. Then the intensity of this emergent polarized light will be I naught by 2 cos square theta. I naught by 2 cos square theta. When you have to use I naught by 2 if incident light is unpolarized. Suppose if incident light is polarized, if incident light is polarized, then the emergent polarized light will be just I naught cos square theta. So in the exam, if they ask what is Malus law, just you write Malus law is given by I is equal to I naught cos square theta. What is I naught? What is I naught? Jerome?
Yes, sir.
What is I naught?
Intensity of polarized light, sir. Of emergent
Incident
polarized.
polarized light. What is, yeah. So what is I? The emergent one. So if they ask Malus law, just you write Malus law is given by I is equal to I naught cos square theta. I is equal to I naught cos squared theta. So please remember this very important concepts. In wave optics, whatever the 2 marks, 3 marks will be there, no. Only few questions, students. One is conditions, then difference between interference and diffraction, then uses of polarite and Malus law, and Eigen's principle. Okay, and you have to prove that I is equal to R and Slen's law. This are the very important 2 and 3 mark question. You will get pakka one question from this. Only this much. Have you got this point, students? Have you got the concept, Jerome?
Yes, sir.
Okay, please, I will send the notes of this wave optics. You can take from sir, and please study that wave optic concepts, the simple one. If you have any doubt, you can discuss in the next session.